I'm Hannah. I'm a tutor at Sky Academy, and we're in the topic of algebra within the Year 11 standard course, and we're looking at linear relationships, which comes under MSA2. So we're looking at linear models in this video. So in the first video, we looked at the gradient intercept formula, which is y equals mx plus c, and we had a talk about what the gradient and what the intercepts were. And then in the second video, we had a look at drawing a straight line graph using a table of values, or drawing a linear function. In this video, we're going to have a look at linear models. So a linear model uses the information that we've learnt so far from the previous two videos, and it's a real life context shown by a straight line graph. So it's applying your knowledge of gradients and intercepts and table of values and a straight line graph to a real life context. And they love to do linear model questions because they love to apply your knowledge to reality. They don't want you just to know what the maths is, but if you can apply it, that's what the NESA, what the Education Standard Syllabus wants you to achieve. So when we're using linear models, we only use the top quadrant of a number plane. So if I'm to draw a number plane here, and by now we know that y is vertical and that's dependent, x is horizontal and is independent, we know that along this part of the number plane, this little line here, we have negative values. Along this part here, the bottom part of the y, we also have negative values. In the top part of the y-axis, we have positive values, and in the top part of the x-axis, we have positive values. So we have positive values in red, and we have negative values in orange. And so the negative values, they go into this quadrant. Obviously, if you're trying to put a point here, it would be at -1, 2, so that's negative. They go down here, obviously, and they go across here. But there's no negative values in this top quadrant here in red. Because if we were to put a point here, for example, it would be +4 and +1. There's no negative values in that top quadrant. So when we're modeling real life, we only use this top quadrant because we can only use positive values. For example, if we had x as time and y as distance traveled in our real life context, we can't have negative time, or we can't have negative distance. It just doesn't make sense. You can't travel a negative distance. So we can't use any quadrants with negative values. So we are only going to use this first top quadrant and forget about the second, third, and fourth. So let's have a go at doing some examples. So here we have a linear model, and it says the graph below is used to convert Australian dollars to euros. Use the graph to convert 50 Australian dollars to euros. So if we have a look at our linear model, we're only using the top quadrant, which we know. On our x-axis, we have AUD, which is Australian dollars. On the y-axis, we have euros. And so this graph is modeling the conversion rate between Australian dollars and euros. So if we have 50 Australian dollars, we have been asked to find how much that is in euros. So if we go up to wherever the line is and then go across, we're going to hit 30 euros. So 50 Australian dollars is equivalent to 30 euros. And let's do question B now. If we have 15 euros, which is here, and we have to go to Australian dollars, we'll go across to hit the conversion point and then go down. And so we have about 25 Australian dollars is equivalent to about 15 euros. So that's one example of a linear model, is just reading off the graph. And let's have a go at another linear model. So water is pumped into a partially full tank. The graph gives the volume of water in litres after t minutes. So our y-axis is the volume of our water, and the t is our x-axis, which is the time in minutes. So question A says, how much water is in the tank at the start? So if we have a look at the volume of the water in the tank, and we go to the start of our line, the start of the line is here at 400. So how much water is in the tank at the start? Well, it'll be a volume of 400 litres. So what this means is that the y-intercept, or where this line would cross, if it was to continue, where it would cross the y-axis, is going to be the fixed starting point. So if your starting point is 400, your y-intercept is going to be 400. If the line started here at 0, then we wouldn't have a y-intercept because it would just be 0, 0. So although the linear model looks different, the same principles apply. That wherever it crosses the y-axis, that would be the y-intercept. Then it says, for question B, how much water is in the tank after 10 minutes? So if we go across onto the x-axis, which is where our time is, and we go to 10, and then we go up to hit how much volume of water there is, and go across when we reach the line, we will get a volume of 1,400 litres. Now if we're to do question C, the tank holds 1,600 litres. How long does it take to fill? So we can see 1,600 here. So if we go across and then go down, it would take 12 minutes to fill. Now question D says, find the equation of the straight line in terms of V and T. So our volume is going to be our y. So if we write down the gradient intercept form, which is y equals mx plus c, our y is going to be our volume. Our m is going to be our gradient, which we don't know. Our x is going to be the t, which is our time, plus the y-intercept. And we already know our y-intercept because that's where it crosses the y-axis. And we discovered before that it crosses the y-axis at 400. So now all that's left is to find our gradient. So let's go ahead and do that. So remember, when we're finding our gradient, we have to get 2 points to make a triangle. So I'm going to, in green, choose this point here of 400 and this point here of 1,200, and I'm going to make a triangle. So my rise and my run. So if I do rise over run, my rise is from 400 to 1,200. So the difference between the two is going to be my rise, and my run is going to be from here at 0 across to 8. So it's going to be a value of 8. So 1,200 minus 400 is going to be 800 over 8. And if you put that into your calculator, 800 over 8, it should just give you the answer of 100. And so that means we can substitute M as 100. So volume equals 100 T plus 400. Now it says for E, use the equation to calculate the volume of water in the tank after 7 minutes. So if we put 7 into T for time, so after 7 minutes of time, if we substitute 7 into T, so it would be 100 times 7 plus 400, that's our equation. You should get 700 plus 400, which will leave you with 1,100. We can check that. If we go across to 7, which would be about here, 7 minutes, and we go up to the line, we can see that from our graph, it would reach 1,100 also. So our graph and our calculations is correct. And that means our equation of the straight line is also correct. And finally, it says how many litres are pumped into the tank each minute. So if we have a look at our formula, we have volume equals 100 litres per 1 minute for each T plus 400. So we start with 400, and then for every minute, it will increase by 100. So that means that 100 litres are pumped into the tank each minute. That is our rate of increase. The fixed term is 400. We start with 400, that is fixed. And then every minute, we increase the litres by 100. So this is our rate of increase, 100.